In a study of helicopter usage and patient survival, among the 35,168 patients transported by helicopter, 326 of them left the treatment center against medical advice, and the other 34,842 did not leave against medical advice. If 35 of the subjects transported by helicopter are randomly selected without replacement, what is the probability that none of them left the treatment center against medical advice? Now, the 5% guideline states that if calculations are very cumbersome and if the sample size is no more than 5% of the population, treat the selections as being independent, even if the selections are actually dependent because they are made without replacement. Then use the multiplication rule for independent events shown below to find the probability. So here is the multiplication. Now, we want to check first if the 5% guideline is applicable in this case. We want to find what percentage of the population of patients in the survey the sample size is. So recall that to calculate a percentage, divide the sample size by the population size, multiply it by 100, and then add the percent symbol. Okay, so we know that the sample size is 35 in our problem, and we know that the population size is 35,168. We want to calculate the sample size as percentage of the entire population of patients in the survey, and then rounding it to 2 decimal places. So the sample percentage of the population, if we take 35 out of the 35,168 times 100%, it gives us this percent, 0.099522293%. Rounding this to 2 decimals gives us 0.10%. Well, the sample size's percentage of the population is 0.10%, and that is less than 5% level indicated by the 5% guideline. By the 5% guideline for cumbersome calculations, the selection of patients without replacement can be treated as independent. Now, we're going to let A be the event that the patient did not leave the treatment center against medical advice. So we want to find the probability of that event A. To find the probability of the event A, we're going to use the formula for the relative frequency approximation of the probability shown below. Probability of event A is equal to the number of times A occurred divided by the number of times a procedure was performed. So a patient did not leave the treatment center can be selected 34,842 ways from the patients in the study. Recall that the number of patients in the survey was 35,168. We're going to substitute these values into the formula and then simplify the probability of event A, and then rounding that to 4 decimal places. So the probability of A, which is the number of times A occurred, is 34,842, divided by the number of times the procedure was performed, which is 35,168, and that gives us a decimal equivalent there. And we're going to round that to 4 decimal places, which gives us 0.9907. Now then, we're going to apply the multiplication rule for independent events repeatedly to find the probability that none of the patients in the sample left the treatment center as shown below. So for the probability of none left, you're going to be multiplying the probability of A 35 times. And another way of saying that is we're taking the probability of event A, which is 0.9907, we're going to raise that to the 35th power. So if we take 0.9907 and raise it to the 35th power, which we can do here. So if we take 0.9907, raise that to the 35th power, then that gives us this result, which is 0.721067140. Rounding it to 3 decimal places gives us 0.721. Therefore, the probability that none of the patients in the sample left the treatment center is 0.721.